truck that meets every federal emissions standard on the road can still leave its driver stranded at 5 miles per hour. That is not a malfunction. That is the system working exactly as designed. Since 2010, nearly every diesel engine sold in America has carried a piece of technology most drivers never asked for, and most mechanics were never trained to fix. A filtration system that can quietly cut a truck's power to a crawl if a single sensor disagrees with a single number. Meet Troy Lake, 65 years old, a diesel mechanic in Cheyenne, Wyoming, who spent decades keeping ambulances, snowplows, and school buses running through sub-zero winters. By the end of this video, you'll understand how one regulatory decision, made without a single public vote, restructured an entire industry's repair economics and turned ordinary maintenance into a legal minefield. Because the story of the modern diesel truck isn't really about diesel at all. It's about what happens when a machine is engineered to protect the air, at the direct expense of the person who has to keep it running. Roughly 70% of America's freight moves on the backs of independent owner-operators, men and women who own one truck, sometimes two, and carry the full weight of every repair bill personally. Rows of parked Class 8 trucks at a truck stop, early morning light. For those operators, a single after-treatment failure, the technical term for the DPF and SCR systems bolted onto every modern diesel engine, can cost $15,000 to $20,000 once labor, towing, and lost revenue are added up. That is not a rare worst-case number. That is a routine bad week. Troy Lake didn't set out to break the law. He set out to keep a snowplow running in negative-degree weather when its emissions system froze solid and refused to reset. He made a decision that thousands of mechanics quietly make every winter: fix the truck or follow the rule. He chose the truck. Under the Clean Air Act, that decision made him a federal felon. The system behind that choice isn't a villain in the traditional sense. It's a regulatory structure, built in stages starting in 2007 and locked into place by 2010, that required every new heavy-duty diesel engine to trap soot in a filter and chemically neutralize nitrogen oxide using a fluid injection system. The goal was cleaner air. The method was a machine that polices itself and shuts itself down when it thinks it's failing. But this is only the surface layer. To understand how we got here, go back to the early 2000s, when the EPA set a hard deadline. Heavy-duty diesel engines had to cut particulate matter and nitrogen oxide emissions by more than 90% within a decade. Engineers at the time weren't confident it was even possible. One engineer, describing the challenge years later, admitted the industry would have to schedule some inventions along the way. That's not corporate spin. That's an honest description of a technology being built under legal deadline pressure, not market demand. The first attempt, exhaust gas recirculation, or EGR, routed hot exhaust back into the engine's intake to lower combustion temperatures. It worked, but it ran engines hotter and dirtier internally, coating intake systems in carbon. By 2010, manufacturers layered on a second system, selective catalytic reduction, or SCR, which injects a urea-based fluid called diesel exhaust fluid into the exhaust stream to chemically strip out nitrogen oxide. Two systems, stacked together, one engine, fewer emissions, more sensors, more failure points. Here's what most fleet managers didn't grasp until years later. The regulation didn't just add parts. It added an entirely new category of skilled labor that the existing technician workforce had never been trained to diagnose. According to industry data, 60% of all after-treatment repairs are regeneration-related, meaning the majority of shop visits trace back to a soot-burning process most technicians learned on the job, not in school. The SCR system in particular became the single most failure-prone component in the entire powertrain, more than the transmission, more than the turbocharger, more than the engine block itself. And the failures compound. A single failed sensor rarely stays isolated. It cascades, triggering false readings in the EGR system, throwing off turbo timing, confusing the SCR's own fault logic, until a technician chasing one warning light discovers 3 more hiding behind it. Diagnostic screen showing multiple stacked fault codes. What started as routine maintenance in the shop bay had quietly become something closer to systems engineering, performed in most cases by technicians who learned it the hard way, truck by truck, breakdown by breakdown. But here's what most people get wrong. Most people assume the cost of emissions compliance is the sticker price, a slightly more expensive truck at purchase. That's the smallest part of the bill. The real cost lives in the repair bay, spread out across the life of the vehicle, one failure at a time. A diesel particulate filter replacement runs $2,000 to $8,000. A full after-treatment component failure, DPF, SCR, and associated sensors together, can climb to $8,000 to $20,000 depending on the engine family. That's more than a year of health insurance premiums for most working Americans, spent on a single exhaust component. SCR catalyst unit up to the camera. SCR catalyst replacement alone averages around $4,000 on a heavy-duty vehicle. Add labor, specialized, dealership-level labor that independent shops often can't perform, and that adds another $1,500 to $5,000 per incident. Then there's the part most owner-operators forget to calculate until it's too late. Downtime. Emissions-related repairs sideline a truck for 1.5 to 2.5 days on average. For an owner-operator, that's $1,500 to $3,000 in missed loads, money that never even shows up on the repair invoice, because it's revenue that simply never arrived. Towing a derated truck to a qualified shop adds another $500 to $2,500. Stack it all together, and the American Trucking Association's estimates that after-treatment and emissions-related repairs now account for roughly 13% of total maintenance costs on a Class 8 truck, a single system category consuming more than $1 in 8 of everything a fleet spends keeping its trucks alive. Here is the counterintuitive turn. The emissions system was never designed with repair economics in mind at all. It was designed to pass an emissions test. The Environmental Protection Agency, by law, cannot mandate fixes for vehicles already on the road, meaning that for 15 years the agency had no legal mechanism to require manufacturers to make these systems easier or cheaper to repair, even as failures piled up. Graveyard of retired after-treatment components in a scrapyard. So a $200 sensor, the kind that can trigger a full derate to 5 miles per hour, routinely cost dealership customers $1,500 to replace, not because the part is expensive, but because for over a decade, almost no one outside a factory-authorized shop had the training or legal clarity to touch it. The clean air came first, the repair economy came second, and nobody designed it on purpose. If you've ever stood in a shop bay staring at a derated truck, wondering how a $5 sensor problem turned into a $5,000 invoice, you already understood something the regulation never said out loud. Compliance and repairability were never the same goal. Diesel mechanics' hands, grease-stained, resting on a toolbox. Most people outside this industry assume emissions rules are about pollution and nothing else. What they don't realize is that the rule also quietly rewrote who is allowed to fix a truck and what it costs when something goes wrong, a second-order effect no press release ever mentioned. Understanding this puts you ahead of almost everyone who has ever complained about a repair bill without knowing why it was that size in the first place. You now know the filter isn't the problem. The sensor isn't the problem. The problem is a regulatory structure built for air quality that was never built for a technician's ability to open the hood and fix what's broken. That gap, between what the rule requires and what a working mechanic can practically do, is exactly what Troy Lake fell into. It's why the Diesel Truck Liberation Act, introduced in Congress, now proposes stripping back some of the EPA's enforcement authority over these systems entirely. It's also why the EPA itself, facing years of pressure, began issuing new guidance in 2025, giving drivers more time, up to 650 miles, before a DEF-related fault forces a full derate. The Lake's case became a rallying point precisely because it wasn't unusual. Mechanics in rural cold-weather regions face the same freezing sensors, the same failed regeneration cycles, the same choice between a functioning vehicle and a technically legal one every single winter. Most of them never make headlines for it. Snow-covered rural road with a single truck moving slowly in the distance. Which brings us to what happens next. Starting with 2027 model year trucks, the EPA's new derate guidance will require manufacturers to change the sequence itself, how much warning a driver gets, and how severe the power loss becomes, before a fault code takes control of the truck. 2027 model year Class 8 truck rolling off an assembly line. Every carrier running mixed fleets will soon be managing two different sets of rules under one roof. And every mechanic will be relearning a system that was already difficult to master the first time. The air got cleaner. The paperwork got longer. And somewhere in a Wyoming garage, a mechanic who just wanted to keep an ambulance running found out the hard way that in modern trucking, doing the right thing and following the rule are not always the same decision.